Hello student, in previous lecture we were discussing about the decoder. Yes, so continuation of the previous lecture, we reach up to the this slide. Decoder with enable input. See student, some decoder are constructed using the NAND gates. It becomes more economical to generate decoder minterm in their complemented form. As indicated by the truth table, only one output can be equal to 0 at any given time and all other outputs are equal to 1. If you observe the truth table of this decoder, everywhere only one of the output is low, remaining all are high. For economical point of view, the NAND gate if you use, in that case we got the reverse output. So NAND is nothing but what? Combination of and NOT. Means what are the output will be generated by the AND gate. It was inverted by using the NOT and output will be generated. In the previous decoder, what we are saying, if every year one of the inputs are 1, remaining are all are 0. Here is exact reverse. We can implement it by using this such type of things. By using the such type of NAND gate. Here, if you are using the AND gate, then it is the table will be inverted. Instead of 1, we can write here 0 and 0 we can replace with the 1. But here 2:4 decoder, same diagram what are the discussed with the previous class. Only here we are using the NAND gate. So that's why output is inverted. Output is inverted. Now moving to the next part, implementation. See, implementation of a full adder with a decoder. Okay. So in number of times in exam, such type of question is asked. From the table, we obtain the function for the combination circuit sum and min terms. Okay. So we can call as the, if you recall or if you remember the full adder circuit. Okay. Their summation xyz contains the summation 1 2 4 7, means this 4 location having the output is 1. Similarly, for carry C xyz, the 3 5 6 7, 3 5 6 7, these 4 ones are exit and their decibel equivalent were it 3 5 6 7. So whenever you implement the full adder, what we have to do, 3:8 decoder means 3 input you can define xyz, and 8 means 0 1 2 7, like this one, 8 output lines we can define. I repeat again, 3:8 decoder. Why 3? Because it contains the xyz. These are your input function. Output are max number is 7. Okay, so 8 outputs lines. That's why we prefer 3:8 decoder. Then after written this x, y, z, what we have to do? 1 2 4 7. See this line, 1 2 4 and 7, right? All are combined connected input for the OR gate. Then this is called as sum. Same logic we can apply for the carry. 3 5 6 7. See, 3 5 6 7. All these 4 connected input for an OR gate, and this is called as carry. So one thing is clear, in OR gate, or you can call it as AND gate also, n number of input is possible. N number of input we can connect. ICs are available. Different inputs ICs are available. Okay, these are the Whenever you implement this full adder, we can implement by using such a way 4 input OR gate IC select. We are having another option also, means quad 2 input OR IC we can use. Both are combined, and we can combine output we can provide to the, like this one again possible. Okay, for simplification circuit we can prefer such type of 4 outputs. Then moving to the next part. Okay, see, implementation same, 1 2 3 4. These truth table are given here only. Truth table of the decoder. See, all zeros. Here is 0 0 0 0 1, then sum is 1, carry is 0. Like these are the truth table. See, 1 2 3 4. The decimal equivalent is 3 5 6 7. Check it, 3 5 6 7. Right, now for here 1 1 1 1. This one is 1 decimal equivalent, this one is 2, this is nothing but 4, and this is nothing but 7. Check it, 1 2 4 7. Okay, so these are the same diagram, function, and their truth table are defined. Okay. Now decoder expansion. Decoder expansion, combining 2 or more small decoder with enable input to form a larger decoder. So 3 as to 8 line decoder constructed from 2 TW to 2 as to 4 line decoder. Means what? We are having the 2 to 4 line decoder, and we want to build a 3 to 8 line decoder. So what is the method, or what is the technique to implement for this 3 as to 8 line decoder? See, the MSB bit is connected to the enable input, and if A2 equal to 0 upper enable, then A2 is equal to 1, it is lower enable. We'll see in the diagram, the picture will be clear. See, these are the decoder, right? So in this decoder, this 2 as to 4 decoder, this is your 2 as to 4 decoder, right? 2 as to 4 decoder. Okay, these both one A0 and A1, A0 and A1 both are connected together. See, this A0 and this one is A1. Means this one is A0, so this one is again A0. This one is A1, this one is again A1. 4 output, this 4 and 4. Okay, so this is your LSB decoder. So D0, D1, D2, D3. Okay, so we can call it D4, D5, D6, D7. Okay, now both enable pins, and we can add the inverter. So what will be happen whenever both 0 0 0, means, see the table of truth table, A0 is 0, A1 is 0, A2 is 0. What will be happen? See, all are 0. In that case, this 0 means what? Due to this inverter, it is 1. It is 1. Means, in the first case, this decoder is active, or you can call that enable, and A2 is 0, so that's why this 0 is applied to here. Means in that case, this is disabled. Okay, so at every time only one of the decoder is enabled and another is disabled. So this one is enabled and this one is disabled. Okay, so 0 0, this 0 means it is 1, so default this line will be selected. So D0 output is 1. See the table, D0 output is 1. Okay, we take any condition. Suppose we can apply this one, 1 0 1. A2 is 1, A0 is, A1 is 0, and A0 is 1. I repeat again, A0 is 1, A1 is 0, and it is 2 1. Okay, so A0 is A0 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 is 1, A1 is 0. Okay, 1 0, and A2 is 1 1 0 1 0 and 1. See, 1 0 and 1 1, so it inverted, it is 0, means in that case this decoder is disabled. But this is 1 means this will enable. Here is what? 1 and 0. So this 1 is applied here, 1 and 0. 1 0 means what? 1. Okay, 1 0 means what? 1. So in that case D5 is active. See, 1 0 1, D5 is active. So in this way the decoder will work. Okay, thank you. In one line, decoder having the many input to many